and welcome to today's webinar. My name is Olga Bodie, and I'm a part of the SYNGAP team. I'm a SYNGAP parent here at the team at Syngap Research Fund. Our presentation today is COMBINEDBrain, Biobank, and our partnership with SRF for SYNGAP1. And I have the pleasure today to introduce today's speaker is Dr. Terry Jo Bishel. Dr. Bishel worked as a documentary filmmaker in the early days of videotape, and then became a public health nurse midwife after filming a difficult birth in West Africa. Her youngest child, Lou, was diagnosed with Angelman Syndrome, and then she switched from midwifery to clinical research on Angelman Syndrome. Eventually, she went back to school and earned a PhD in neuroscience from Vanderbilt University in an effort to find treatments for her son. Along the way, she studied gene-environment interactions in Huntington disease, as well as circadian aspects of Angelman syndrome, and was a columnist for the HD Buzz. After graduating, Terry Jo was the founding director of the Angelman Biomarkers and Outcome Measures Alliance until 2018. Dr. Bishel founded a new nonprofit in 2019, COMBINEDBrain, which stands for Consortium for Outcome Measures and Biomarkers for Neurodevelopmental Disorders. And this is to assist other rare and ultra-rare neurogenetic disorder with clinical trial preparations. A recorded version of this webinar will be available on the SRF website under webinars on the family menu. And by the end of this presentation, you will have the opportunity to get the answer to your questions. We'd love to hear from you. Please write questions in the Q&A below. For those of you joining us, welcome. And again, our speaker today is Dr. Terry Jo Bishel. Her presentation today is COMBINEDBrain, Biobank, and our partnership with Syngap Research Fund for SYNGAP1. It's now my pleasure to turn things over to Dr. Bishel. Thank you, Terry Jo.
Thank you so much. Thank you for having me here. I really love working with the Syngap Research Fund, and I think this is really an honor to talk to you about what we do. So I wanted to start out with just a little bit about me and my motivations. I don't usually talk about it that much, but I want to let you know some of the backstory. So let me share my screen. And I will put it into slideshow mode. There you go. And so basically what I want to tell you about is why I started COMBINEDBrain, which is a consortium of, we are up to now 65 patient advocacy organizations. And each of these patient advocacy organizations represents a whole disorder. All of the disorders that we that are included as member organizations in COMBINEDBrain, they're all rare genetic neurodevelopmental disorders. And the reason for that has to do with my own personal story. So that's what I want to tell you about. So this picture is a picture of my son Lou Bishel and me at our daughter's wedding. I have 5 children, and Lou is the youngest. He's 24 now, and when he was and he has Angelman syndrome. When he was born 24 years ago, we didn't have a clue. And I'm going to tell you a little bit of that story, which I think is exactly the same as your story for all of you who are parents of people who have SYNGAP1 mutation. So this slide deck came from a presentation I made last year in Park City, Utah, where they had a beautiful gondola ride. And so I will mention that, but it's really about luck and it's about grit, and this is my favorite subject. I always have to say that I do get an honoraria from Hoffman LaRoche for being on an Angelman patient advisory board, but that's it. I do not have any other pharmaceutical money coming into me. So what happened to me was that I ended up going after my son was born and realizing that he had a disorder that had at that time no treatment at all. I launched into the work and into the research, trying to see what I could do to help find a treatment for him. And I actually got a little bit frustrated at a certain point because the treatment wasn't moving along fast enough. So I went back to school as a middle-aged lady and I got a PhD in neuroscience. Um, and this is a picture of me on my graduation day with Lou, who by then was already in his late teens. So it took me 7 years to get that PhD. It was 7 years well spent. I learned a ton. And actually, what I studied was not Angelman. What I studied was Huntington disease. And in fact, that is actually kind of important to me because I learned that by studying Huntington's disease, I could actually learn a whole lot of information that would help me to treat Angelman syndrome. So, in fact, that's also what helped me decide to start COMBINEDBrain, because I realized that we could learn so much from each other rather than just staying in one silo about one disorder. We can actually learn from what everyone else is doing in a similar field. So anyway, let me tell you a little bit more about Angelman syndrome. With Angelman syndrome, it's a mutation on the mother's 15th chromosome. So if you look at this little diagram here, what you can see is that the green is the chromosome you get from your father, your 15th chromosome. And the green shows that from your father's chromosome, it's perfectly good in Angelman syndrome. And what you get from your mother's chromosome has a mutation. In my son's case, he has a deletion. So he's missing a chunk of his 15th chromosome. So there are these other ways of getting Angelman syndrome. You can have a mutation. You can actually end up with 0 of your mothers and have 2 of your fathers, or you can end up with just a mistake that makes the chromosome look like it's from the father when it's really from the mother. So why does that matter? It matters because it turns out that in everybody, your paternal chromosome on this one section of the 15th chromosome is silent. The father's genes right there are silent in neurons. So it's only the mother's genes that are expressed. And so if you have a mutation on the mother's side, you get Angelman. Weirdly enough, if you have a mutation on the father's side, you get a totally different disorder. It's called Prader-Willi syndrome. And so it's a disorder of imprinting. This is kind of important because it's the way we figured out how we could actually treat this disorder. So there's just like SYNGAP for most of the cases of SYNGAP mutation, it's just bad luck. It's de novo. Everybody has the same chance of getting it. There are no known risk factors for most of these mutations that cause Angelman syndrome. It's just a spin of the roulette wheel. And Angelman is about 1 in 10,000, supposedly, incidents of live births. And every woman is born with 10,000 eggs. So really, every woman born has the same chance of spinning that roulette wheel and getting that egg with a deletion or a mutation. So this is a picture of my son Louis when he was a baby. He was really cute. He was really smiley. He was really cuddly and affectionate. And believe it or not, it turns out that's a symptom of Angelman syndrome, which I have to say, it could be a lot worse. I mean, the fact that one of the symptoms is being happy and smiley and cuddly and affectionate, that's actually quite a godsend. So what happened with Lou was that we started to notice that things were not going well with him when he was in his babyhood. I mean, because I had 4 other kids, I really knew, and I was a nurse midwife at that time. So I helped all kinds of people breastfeed. I helped them, figure out how to handle their newborn babies. And so I really thought there was something not right about the baby. And I'm just going to go back to that slide where it shows you again how smiley he was and sweet. And yet I knew there wasn't something right. And I kept carrying him to the doctors. My husband's a doctor. All our friends were doctors. And so I would take him to a party or a picnic or whatever. And I would say, look at the baby. There's something the matter with the baby. What's the matter with the baby? And I'm sure everybody thought I was crazy, but I knew there was something the matter. I knew so well that I actually enrolled him in a study of communication at the age of 4 months. I told everybody, my friends and relations, the baby's not communicating with me. And they all thought I was nuts. Because how can a 4-month-old baby communicate? But once you've had a couple kids, you know that they do communicate with you. They give you eye contact. They try to get your attention. They respond to things you do, and he wasn't doing that. And yet at the same time, he was smiling and cuddly. Anyway, it was hard to figure out, but I enrolled him in this communication study at UCSD because we lived in San Diego then. And they did a whole battery of tests on him for a whole entire day. And in fact, he was rolling over then, which was the right appropriate month for him to learn to roll over. And at the end of the day, they gave me the results and they said, he can't be a control. Okay, that was bad. They meant that there was something. There was something the matter. So we knew there was something, but nobody could figure it out. And I still kept asking every doctor friend I knew, look at the baby, look at the baby. And my husband and I had a book called Congenital Malformations in Humans. And it was the old way that people figured out what genetic disorders there were, because we really weren't using the internet well at that point. And so everybody had this textbook. If you were in the field of pediatrics or midwifery or obstetrics, you had this textbook on your shelf. And we would shuffle through all of those pages. And every time we came to the Angelman page, I'd say, isn't that funny? He looks a lot like the people on this page. And my husband would look at it too, and we would think, yeah, but he can't possibly have that because he's so bright. And I don't know if that's because we were in denial or if that's because intelligence is really complicated. But what I knew then was that he had such a good sense of humor, we thought he had to be really smart. Well, like I said, it turns out sense of humor is a symptom of Angelman syndrome, and cognitive disability is also a symptom of Angelman syndrome. So finally, a year later, after bugging everybody we knew, we got a blood test. And the one blood test they drew was for Angelman syndrome. And so we had the diagnosis of Angelman, which was devastating because they told us he would probably never walk. He would probably never feed himself. He would be dependent his entire life. He would likely never move beyond a 1-year-old developmental stage. He would likely have terrible seizures. He would never sleep, and he would live a normal lifespan, meaning that we needed to find a way to take care of him for at least 35 years after we were gone. It was a very scary diagnosis. So weirdly enough, I was in Mexico at the time working at a Mexican midwifery school. There really wasn't internet anywhere near me. I had to walk down this path in beautiful San Miguel to the nearest internet and pay for some of the internet to be able to look up Angelman syndrome. And what I saw there was that there was a conference in Finland 6 weeks later. So I packed up my mom, my intrepid mother, and the baby, and we flew to Finland in July when it's the midnight sun. And we were up all night because people with Angelman don't sleep, and there was sunshine all night in Finland in July. And I was pacing the lobby with the baby so my mom could get some sleep up in the room. And at 3 a.m, there was also Dr. Baudet, Art Baudet, also hanging out in the lobby because he couldn't sleep either. It turns out he was the man who had identified the gene for Angelman syndrome just a couple years before that. This was 2000, the year 2000. He had identified the gene in 1996. And I got to know him in the middle of the night in the lobby in Finland. And one of the most amazing things about him was that he thought Angelman syndrome could be cured. That was pretty cool. Nobody else I knew thought that anything genetic could be cured. And by the way, people still think that. People still think that just because it's genetic means it's incurable. And in fact, nothing could be farther from the case, because now, 23 years later, we happen to know that having the genetic cause, knowing the gene behind the disorder, makes it eminently possible that we might be able to find a treatment or a genetic-based cure. So that was a fantastic piece of information or news for me to hear at that point in my son's life, and it set me off into the research. And I've always felt like that was incredible luck, that it was incredible luck to get his diagnosis just in time to make it to the first ever international meeting. It was incredible luck to meet Art Baudet in the lobby in the middle of the night, 3 or 4 nights in a row, and chat with him about the possible research. And I've always felt like a lucky person. And I talk about this a lot. I won't belabor it today, but there are a lot of things that I think we're lucky about our life and my life. And about being a person with Angelman syndrome, because right now, if you're a person with SYNGAP or a person with Angelman syndrome, it's a pretty damn lucky time to have been born. Because if you were born 30 years ago, you really had nothing. But you're born now, there's a lot of hope. So at any rate, at that point, Art Baudet had this idea that maybe we could turn on the paternal gene. Remember that paternal gene was off in everybody, but it's just sitting there, perfectly good. Why can't we just turn it on? So he had a great idea to try to turn it on with methylating agents, and those methylating agents were actually over-the-counter supplements. So in fact, I helped him start, and with a lot of other people, the very first trial, human clinical trial in Angelman syndrome, which had to do with trying to turn on the paternal chromosome with these methylating agents. And then I'm going to fast forward to 10 years later. That did not work. That particular trial, we were not able to turn on the paternal chromosome. And there were a couple other trials started, also looking at the paternal chromosome, trying to activate it, that didn't work. And then we also tried a Parkinson drug, and that didn't really work. And we had a few clinical trials. And at that point, I started thinking, nobody cares about this as much as me. All these academics, they're just trying to get their next grant. They're trying to publish. They're not trying to cure a kid. It's going to be up to me. Well, that's pretty silly because anyway, it turned out other people did fantastic stuff and most of them were academics, and there are fantastic academics. But that was what I thought at the moment. So I thought, all right, I'm going to get a PhD and do it myself. So I was probably the oldest person to get a neuroscience PhD at Vanderbilt. I don't know if I'm the oldest person in the world to get one, but I was pretty dang old because I was 50 when I started it. And I did start out studying Angelman syndrome. But in fact, I had actually some really fantastic good luck working in the lab. Luck again, there it is. We made stem cells, and this was a while back now, like 14 years ago or 12 years, I don't remember exactly when, but stem cells, iPSCs, were kind of new on the scene, and it was hard to make them. It was not a simple protocol, and I got lucky. I made stem cells in my first try, and I was able to get some really good work done. And then unfortunately, my boss quit. Not the boss in this picture, a different boss. And that's why I had to move into Huntington. But I did learn a ton about Huntington. At that moment, I really had to make up my mind. Did I want to stick with it or quit? Because I wasn't going to be able to study Angelman anymore. I was going to have to study something else. And at that point, I thought, you know what? I've already finished. I thought I'd already finished the hard part, which is also laughable. But I don't think you could do a PhD as a middle-aged person unless you're pretty naive about how hard it is. But anyway, I turned over all my experiments and my data to Dr. Carl Johnson's lab, and he worked on circadian aspects of Angelman syndrome, and they actually found some fantastic stuff, and we published a couple papers on that. So it all worked out. Those experiments got done, and then I joined this lab and studied Huntington, and I'm still working with some of the people in that lab today that are actually working for COMBINEDBrain. So that, in fact, was also a happy and lucky end to that story. And now, if you fast forward in Angelman syndrome, we have so many treatments coming down the pike. And in fact, other people, while I was in the middle of making my stem cells and studying Huntington, a lot of other people came up with fantastic treatment strategies for Angelman syndrome. And so what it turned out by the time I graduated, so these were the studies, these were the companies that were in the field when I graduated. So it turned out by the time I graduated, what we really needed were biomarkers and outcome measures. We really didn't need more drug discovery. In that 7 years, while I was buried under the hood, the stem cell hood in the lab, all this happened. But we still had to have biomarkers and outcome measures. So I ended up being drafted by the two foundations, which at that time hated each other. And that happens a lot in the rare disease field. But I tried very hard to stay in contact with both foundations. And so they both hired me to run this thing called the ABOM, which was the Angelman Biomarkers and Outcome Measures Alliance. And what that was an opportunity to try to figure out how we could possibly measure whether any of those cool treatments that were coming down the pike would work or not. So we had to convene everybody we could think of who were experts, most of them who were competing with each other. Industry groups who were competing, academics who were competing, foundations who were competing. We had to get them all to work together to try to come up with the best biomarkers and outcome measures. So I did that for a couple years, learned a ton. and then decided to form COMBINEDBrain. And COMBINEDBrain is the A-bomb on steroids. So COMBINEDBrain is everything we learned in the A-bomb, only better. So we're trying to come up with outcome measures and biomarkers for 65 different disorders at the same time. It sounds pretty crazy, but it's actually working, and it's working amazingly well. So, first of all, do I get to ask for questions in the middle of this, Olga? Or am I supposed to just go on and on for how long?
You can go through the presentation and then we'll do the questions. I think that might make it easier.
Okay. How
Okay,
much more time till should I, because I have like 10 more minutes I want
that's
to.
fine. You're good. You're good.
Okay. So this is basically a slide that sort of tells all the different things we do at COMBINEDBrain. So at COMBINEDBrain, the step one is the disorder has to have a gene identified. Actually, we do have one disorder that doesn't have a gene identified, but they're hot on the trail. But normally they have to have the gene identified. And once they have the gene identified, then we have to find the patients. So these are all projects that we're working on to find patients. Project Find Out, we try to find kids under the age of 12 months, which is actually really hard because a lot of COMBINEDBrain disorders are like Angelman with my kid. You know, the baby doesn't look quite right, or might even have something like seizures and trouble eating or hypotonia or motor difficulties, developmental delay. But most of the time, doctors just keep pushing them down the road and say, oh, they'll be okay, they'll be okay, they'll be okay. They don't get diagnosed right away. So we have Project Find Out to try to find these patients under the age of 12 months. We work with the Beginnings Project, which is doing universal newborn sequencing in San Diego and in Memphis, Tennessee. I'm in Tennessee now. We moved to Tennessee about 16 years ago. We also do all kinds of work to help all the different disorders in COMBINEDBrain come up with ways to find repurposed drugs as fast as they can, to find the cell models, and then to test those drugs to see if they might work in low throughput screens. That means like in a plate that only has a few cells on it, or in mouse models. I'm going to talk about the biorepository in a minute. So let me get to that in a second, because that's what I'm really going to focus on. But we also do all kinds of rent-a-brain projects. We have scientists on staff, some that worked with me in the Huntington lab, and some other ones, new ones. We have postdoctoral scientists, we have grad students, we have undergrad students. Everybody has to care about translational neuroscience, meaning they have to care about everything from the science to the kid who's going to get the treatment and everything in between. So we help with all our different groups with whatever they need from a scientist perspective. We also help our groups figure out how to collect natural history, what questions to ask on natural history, how to publish natural history. We do disease concept models, and we're doing a disease concept model right now for SYNGAP. It just got started. And in a nutshell, a disease concept model is a way to figure out what matters to patients. And how do you figure that out? You ask. So we actually go to patients' families, to the parents of kids with SYNGAP, and we ask, what is your life like? What is your nighttime like? What are meal times like? What do you do for fun? We ask open-ended questions because we want to know from your patient, your family's perspective, what is your life like? And that's really important, because from doing that, we can figure out what we really need to try to measure, what we really need to treat when we come up with the treatment strategy. And then we help people get ICD-10 codes. Thank God you all have one already. We also then figure out, let's say we figure out Well, what you need to treat, what's really troublesome to SYNGAP families is communication. And so that might be the endpoint for clinical trial that's the most important. So then we have to find out, well, is there a way to measure a change in communication, an improvement? So we took a survey that was being used in Angelman syndrome, because I steal as much as I can from the Angelman field and use it in all these other fields. And that was called the ORCA, the Observer Reported Communication Abilities Measure. It's a survey. And so we then tried to expand it to 12 other combined brain disorders, including SYNGAP. And we have a lot of other things like that too. We found out that another thing that was really important to families is the toileting abilities. Is a kid able to use the toilet independently? And if not, what parts of toileting can they do? Can they tell you, do a sign when they have to go to the bathroom? All those things. So we have a new measure that we're developing to try to develop how a kid is progressing towards independent toileting, which in my family's life is really life-changing. If my kid at 24 years old could completely toilet himself, it would make it possible for him to go to different facilities, to different programs, to all kinds of different things. Right now, he still needs help. And so any improvement in that would be fantastic. And then we also help all the groups go to the FDA, talk to the FDA, talk to the NIH, apply for grants, and then design their clinical trials. So we do all those things at COMBINEDBrain. But our big project right now, the biggest project is the biorepository. And I'll tell you why. Let me see what my next slide is. My next slide is not exactly the one I wanted to tell you about. So I'll go back to this slide. Whoops. And talk about the biorepository. So the biorepository, one thing we found out is that for all of our different combined brain disorders, they might have stem cells at one university, and they might have plasma at a biorepository, or they might have early stem cells, but not completely validated stem cells in a company that was going to do a clinical trial. And they're all over the place. So if somebody wants to study SYNGAP, and maybe they might want to compare it to another synaptic disorder like STXBP1 or a DLG4 mutation, for example. And so they might want to have plasma from SYNGAP1, STXBP1, 6A1, and DLG4, 4 of our member disorders. They might want to have those, but to get those stem cells or plasma from all 4 of those disorders, they might have to go to 25 different institutions. They would have to sign contracts with each institution. They would have to have IRB approval for each of those different things. It could slow down research by years. So what we realized is that if we created a biorepository for combined brain disorders, we could actually make it one central place where researchers and industry could get all the samples they need quite easily. And what we wanted to do was make it so that all of those samples were actually governed by your own foundation. So you have a say in who, your foundation has a say in who studies your disorder. Let's say that one professor in Toronto decided to study SYNGAP, and they request every single one of your samples. That might not be so good. If we were just a regular biorepository, whoever came first come, first serve could request those samples. In this case, your foundation can have a say and say, no, we can't release all of our samples to one person. we could release a few to that person and a few to somebody else. And meanwhile, we can go out and collect more. And we also, when those people end up paying the fees to be able to get those samples, we return some of that to your foundation so that your foundation gets to decide what samples they want to make and where those samples get distributed. And then it goes back into your foundation so it's sustainable, so that you can keep putting more samples in the biorepository. So what's really cool, I'm going to stop sharing for a second, about the biorepository, we started building it. We only opened it not even a year and a half ago. And luckily, SYNGAP was one of the first groups to put samples in the biorepository, which is fantastic. And we already have now 400 individuals represented in the biorepository across a lot of combined brain disorders. Some of those are patients, and some of those are their siblings or their parents. So we have patients and controls, meaning we have blood or stem cells or plasma in the biorepository from both patients and controls. And the thing is, it's kind of like the field of dreams. Once you build it, they will come. And so what happened, we started the biorepository. Your foundation was one of the initial ones. You put samples in, you made stem cells out of those samples. Industry learned about those and the others and the fact that we had controls. And we now have a biomarker study, which will be funded so that in fact your own foundation does not have to pay for it. And yet you will actually get the data from that. It's not just for SYNGAP. It goes across 20 combined brain disorders. And that's fantastic because they can compare, for example, all those synaptic disorders, the biomarkers to each other. And they can also, it makes it more accurate because if something is increased in SYNGAP but decreased in STXBP1 and the same and not changed in the sibling controls, for example, that shows you that it's probably a pretty good biomarker. So we have a biomarker study now. We have another biomarker study that goes across every single combined brain member disorder. All you have to do is donate your patient's blood sample and hopefully also sibling controls, because they're really important to have too, age matched or right around the same age or from the same family. Go and do that donation and your SYNGAP can participate in those biomarker projects. So what's really cool about this, and I have another slide, but I don't want to waste time finding it. So we're calling it the Biorepository Roadshow. So what we've gotten is permission from all these different foundations who happen to be having family conferences this year all around the country. I think we're missing the Seattle area, but all the rest of the regions of the country are having a family conference. And so we've gotten permission from all of those different groups to have the combined brain team go to the conference for free and collect samples from anybody in those cities who wants to come in for half an hour, give a blood sample. We'd like you to bring some pee too, if you wouldn't mind, and answer a survey. You always have to answer a survey. The Vineland, everybody's favorite, but you can do it from home. A survey about seizures and a few things about your own self, where you live, socioeconomic, ethnicity, things like that. That's all you have to do. And you don't have to go far away. You can do it in a city near you with the Biorepository Roadshow. And so by doing that, you can participate in Combined Brain Biorepository and in the biomarker projects. And SYNGAP1 is highly sought after right now. So that's a really good sign. It means that there are a lot of groups that want to do research and try to find a treatment for SYNGAP. So that's my spiel, and I'd love to answer any questions.
Thanks, Terry Jo. I really appreciate you doing this. As you guys probably figured out, Terry Jo needed more things to do, like she needed a hole in the head. And I asked her to do this because A, I talk about her a lot and I wanted you guys to see her in person. But B, this biomarker, well, there's three reasons. A, what I just said. B, it's important to realize that we're not figuring this out for the first time, that people like Angelman and Dravet and Rhett have gone before us, and we'd be stupid not to follow right behind them and learn as much as possible. And by joining COMBINEDBrain very early on, we were one of the early joiners. We are doing that. We are actively working hard to benefit from Dr. Bichel's generosity, because quite frankly, if we cure SYNGAP in 20 years, the odds of me starting a new organization to help the next 100 genetic diseases is close to zero. Like there's actually no chance of that happening. So I'm very grateful that Terry Jo has taken this on. From what I can tell, there's nothing in it for her. But the third thing, I really want to double click on this, because Dr. Bichel, you just said so many important things. There are sponsored biomarker projects happening through COMBINEDBrain. This is huge, right? I want to be clear for the audience. Before this happened through COMBINEDBrain, people were coming to us, and they still are, and we might do a side project, but asking for like significant amounts of money to look for a SYNGAP biomarker. And it was like a major undertaking. And it wasn't just an undertaking of give this scientist a bunch of money. It's give a scientist a bunch of money, figure out which platform to use. Those are two really big things. And figure out the logistics of getting blood out of, because you can't do it with 3 patients, right? You need dozens of patients. How are we going to get samples from 50 patients and their siblings in one place? Oh, are we going to fly 50 families to one place and collect them? Or are we going to fly someone around the country? And I mean, it's a logistical nightmare that honestly I was stuck on. And then COMBINEDBrain rocks up and they're like, we have all these members, we're going to have all these conferences, we'll just collect samples everywhere. Terry Jo, I can't believe you didn't say it. This past weekend in Boston, Grin had a conference. We collected samples from 3 Syngapians. That's 3 steps closer. By the way, the goal is at least 50. It's a Mike goal. And we're going to get there. So I think I think this was billed as learn about the biorepository. So I would encourage questions on the biorepository. And the takeaway is, just in case you want the right answer for the quiz at the end, is find a way to get you and your loved ones to a place where you can give samples. And Terry Jo, we should talk about why it would be good to go to a COMBINEDBrain collection as opposed to just the Quest in the back of Safeway down the street.
Yeah, that's a good idea. Yeah. So these biomarker studies, they're done on blood, which is really good, because before that we had to do biomarker studies on cerebrospinal fluid, which you have to get from a spinal tap, and nobody likes that. So these studies are from blood, but you have to spin the blood down immediately. You have to separate it into plasma, and you have to flash freeze it. So you have to do that within an hour, and you have to do it all the same way, which is why we have our COMBINEDBrain teams going to these conferences so that we're processing it all exactly the same way. So the biomarker studies, they don't work as well if you don't do it right like that. So we have to do all of that. That's why we need you to walk into one of these COMBINEDBrain conferences and do it there. I see a hand up from Olga.
Go ahead, Olga.
Yes, Terry. Hi. Quick question. Can we get a list maybe to promote this as to all the different locations you're at? Just because I know we have our family conference in December, but like if there's something going on in Houston, maybe it might be easier for me to get everybody there.
We do have a list. It is a working list because we're still getting the final formal permissions from some of the different foundations to be able to collect at their conferences, but you all will get the list so that you can put it on your own website. So you can put it on the SYNGAP Research Fund website, and so that you all can send it out in your own newsletter or your own materials. We'll be
Okay.
sending it out too, but the list today isn't fully complete, but you will have a list really soon. And in fact, once you have it, if you have this website post, if you have this webinar posted, you could
We'll add
just
it.
put it right under this
We'll add it.
webinar, and you can.
Yeah,
Oh.
so we're definitely going to do that. But the big point here is this is a very precious study. This is going to happen sometimes towards the end of the year, maybe early next year. And it's really, this is the year for sample collection. So when we do post this list, try to get yourself to a collection site. Definitely, you should be coming to our conference anyway. If there's a collection site near you and you're coming to our conference, I'm just taking a flyer here. Go to the conference near you, because for two reasons. A, get the sample processed in the biobank, ready for sharing, right? And B, we have one of the last conferences of the year right before AES. I'm actually thinking that our collection room is going to be pretty crowded. I think a lot of people are going to figure this out. And AES is at Orlando. A lot of people are going to bring their kids. Oh, just go to the SRF conference. That's fun anyway. So I would strongly urge every family watching this, figure out when the nearest collection to you is as soon as possible and get it done as soon as possible. Because those samples, we're going to take plasma, we're going to put them into at least one, maybe multiple biomarker screening projects, and we're going to try to find a biomarker for SYNGAP. I have a speech on this, but since we have Dr. Bichelle, can we go one-on-one here? Like, why does the biomarker matter? What is this biomarker? Who cares? What is this?
Yeah.
Is it just science?
That's a great question. So here's the thing. You treat SYNGAP. Let's say you give a gene therapy and it works. How do you know if it's working or not? So hopefully your kid with SYNGAP will jump up, ask to pass the salt, go into the kitchen and wash all the dishes, right? But it's usually not like that. Usually what happens is that it's a very slow progress. If it's working, what you won't see is some miracle the day of the first treatment. What you hope to see is slow, steady progress. So if you're a pharmaceutical firm, you've invested all this money in this treatment. You have to know, is it actually doing what it's supposed to be doing? So you, the family, have to report on, is your kid or the adult with SYNGAP doing something better or worse, but hopefully better than they were doing before. You have to report that. That's really crucial. But it might take a while. It might take a really long time. It might take months. It might even take years to really kick in. So if that's the case, why would the company stick with it? Because if they can't see immediate results, if the kid doesn't jump up and say, pass the salt, then how do they know if it's actually working? Well, how they know is because they could see some marker, some biological thing that says the gene settled in, it's making more SYNGAP, the gene is doing what it's supposed to be doing. Now we just have to wait for the brain to kick in, for everything else to start working. So if you have a biomarker that shows that the gene is doing what it's supposed to be doing, even if you can't see a big improvement right away in the patient, you can stay the course because you can see that the gene is doing what it's supposed to be doing. And that means hopefully it should, in the end, improve your life. That's why a biomarker is important.
Thank you.
Okay.
Any other questions?
I have one more, Mike, just out of curiosity, with the International Epilepsy Society overseas, is that something we can do across the pond, or is it just within the US right now?
That's a really good question. And I'm sorry to say right now it is only in the United States. We have our sights set on overseas and right now, especially Europe, but it's not going to happen this year. All of the collections for these biomarker projects have to be done by December. They have to be done by December. It doesn't mean there won't be another experiment after this, but the ones we're talking about right now, we're doing them all by December. In January, we ship them off. So everybody's got to get them this year. I think there was another question maybe in
Yeah,
the
I just gave her permission to talk. We have another parent here who's a fellow PhD level scientist. Yulia, you want to just ask your question?
Yes, absolutely. Well, first of all, thank you so much, Terry Jo. This was fantastic. Thank you. Very inspiring. And, you know, we all need hope. So I have one quick question. If there is no sibling, do you collect from parents? What is that an issue?
No, it's not, because we can use age match controls from other families to match the person with SYNGAP, but we would like to collect from the parents as well. We
Okay.
won't use every project won't have the same controls. So we might not use the parent samples right away, but we don't want you to think they're a waste because those controls are also very important. So if you could give parent controls, that would be good too. Your foundation will end up covering the cost of storage for those samples, but it's 10 cents a month per tube. So I think you guys could sell enough brownies to pay for that.
All day long.
Okay.
All day long.
And
Go ahead.
sorry, Mike, I have another question. This one's more loaded, and the answer is probably no, but I'm really curious about the measurements that you will be, you know, collecting and analyzing. Is that list available by any chance, or what are you going to be looking at? Yes.
So in these two projects that are coming up now, they're looking at plasma. So they're looking at various plasma markers, which if you have studied this, you know would either be protein expression or gene expression.
Okay. Wow. So all these big kind of omics studies then? That's
Something along those lines, yes.
nice.
Yulia, let's talk one-on-one.
Yes. Sorry. Okay.
No apologies. I just there are a variety of NDAs in play. Let's talk.
Okay. Okay,
And then-
somebody else, Lauren. Oh, Lauren has.
Oh, hi. Oh, I got it off Facebook, but David Peterson, he's wondering if we happen to have a gathering of a bunch of SYNGAP families, how many would be enough to get a COMBINEDBrain team to visit to collect samples? He says we've got several.
We would rather you have that gathering at one of the places that's already having a conference.
Okay.
Because if you do that, we've already got a space there. We've already got permission to do the collections there. We've got a phlebotomist whose whole job is to, you know. So if you want to do that though, you can. And I think Mike, I've already given him a bid on that for how much it would cost, and we can circle back. But if you plan your gathering at a conference, the cost is $0.
And because there are some sponsors who have already agreed to cover X conferences, right? So I think that the audience needs to understand, you know, as we need a phlebotomist, we need an IRB, we need a room, we need somebody who's trained to stick kids and adults. We need someone else who's a PhD level scientist who then takes the samples and spins them down, right? And then we need it flash frozen, and then we need a big fat shipping label to send to the big fancy lab where COMBINEDBrain has a part. That there's a huge amount of complexity here that all costs money. And the beautiful thing about COMBINEDBrain is industry is sponsoring big chunks of this, so our cost is very low. There is a cost to collection, there is a cost to supplies, there is a cost to storage, and SRF happily covers all these costs. And we also happily encourage you all to do birthday fundraisers and all the different fun. Thank you. Do keep doing the fundraisers. But like, I want you to understand, one of my agendas here is for everyone in SRF to understand the staggering, well, I'm staggered because I'm not a scientist, but like the complexity of getting this stuff done is really high. And this combined brain is such a gift because it takes on a lot of that complexity by bundling us, and Terry Jo raises money and she hires great people, Kristen and Anna and all these incredible souls. So I just want you guys to understand the whole chain here. But David, your point is taken. I've asked the same question. And if we do have a big West Coast gathering or something, we will bear the cost of flying a couple people out, paying a phlebotomist, covering all those costs. But the real push is to get us to, and frankly, crashing other rare disease conferences is kind of cool because you sit in the back and you're like, why aren't we doing that? And then you know, and Terry Jo, I want to, while I'm doing just random unsolicited advertisements, I have recently gone on the mission. So, you know, within our community, like so many, there's the protein truncating variants who are nonsense and frame shift. We know that therapies work for them. And there's the missense variants. And it's less clear what we need to do, a lot of work to understand what missense mutations are doing, right? And so in addition to collecting the blood, banking the plasma, making it available for biosamples, the partnership with COMBINEDBrain allows us to make stem cells and isogenic controls. And one of the things I say to families ad nauseum is you don't know how lucky you are to be able to just raise $10,000, 10, 11, whatever, to make a stem cell and an isogenic control. Like this is pretty recent, and 10 or 11 is kind of a screaming deal. Agree, disagree?
It's really true. I mean, when I started my PhD, you know, making a stem cell line was $50,000, $100,000. Recently, very recently, it was like a year ago, it was always $15,000. We've gotten, because we're doing a lot of them, we've found a way to do it with certain labs that is a whole lot cheaper. And so what also happens is that if you get an extra tube drawn the day that you come in to draw the blood for the biomarker projects or for the biorepository, if you get an extra tube drawn and you put that in the biorepository, your foundation can decide if they want to process it into different parts. So PBMCs is one of the parts. And if you freeze down those PBMCs, you can decide anytime in the future whether you want to make stem cells out of them or not. So if people need stem cells in the future, you would already have those PBMCs in the freezer, in the biorepository, ready to make stem cells. That's another really amazing thing to do this year while you're donating to the biorepository. Donate an extra tube like that if the foundation's willing to do that. So then if you make stem cell lines from all these different patients with all these different mutations and maybe different phenotypes, like some people more severe than others, maybe you can actually figure out why is it that some people with the same mutation are doing better than others. And maybe you can actually use those stem cell lines to try new drugs and new technologies and new treatments. So yeah, it's really, I'm really, really proud of what we've done here in a short space of time at COMBINEDBrain. And we're getting requests for those stem cells that are made every day.
Yep. And anyone paying attention at SRF knows that we made a bunch of cell lines of rare base. That phase has happened. We are now making all our cell lines with COMBINEDBrain. And I have said on my podcast repeatedly, scientists and industry meets us. They hear we have cell lines. They do not look at the list. They do not finally analyze. They say, how many cell lines do you have? I say, we have 6 at rare base and 3 over here and 4 over there. And they say, yes, I will take them all. Because remember, guys, these are not unlike plasma. So plasma is precious, right? We draw it, we use it up in tests, it's gone. Cell lines, you make them, and then they're immortal and they're expandable. Is that the right word? So yeah. You can make more out of the line you give. So once you give and create, once we create iPSCs from your patients, we can then reproduce them and make as many as we need, right? Industry pays like small change to get these things, but we use that money to expand them into more and more and more. And we not only make a cell line, but we make an isogenic control, which is where we use CRISPR to take the mutation out. So in the personal example, we make Tony's cell line, which has Tony's mutation, and then we CRISPR out Tony's mutation, and we say, this is what it would look like if Tony was normal. So we can do something to the mutant.
If Tony were in a dish.
Yeah, Tony in a dish. It's so I really encourage families, give blood to the biorepository. We need the plasma in 2023. That's the headline. By the way, you could also have an opportunity to give an extra vial. Yeah, whatever it costs. We'll spin those down so that when you realize, oh my gosh, I want a stem cell line, we can make it.
Mhm.
People are so sick of hearing me say that, but I'm just going to keep saying it.
So I gotta say, people a lot of times have questions about this. I don't know if your community does, but we might as well answer them if we can. But a lot of times people have questions like, who's going to use my kid sample? Or why would I contribute to some company who's trying to make a profit? Okay, let me tell you something. My kid, I have written the same letter to just about everybody. I say, I renounce HIPAA. I want no privacy. I want everyone to know everything about my kid and me and my husband. I don't make all his siblings do that, but because we want to find a cure. And so, yes, if a profit-making company wants to use my son's cells in order to look for a treatment for my son's disease, I hope they make it and make a great profit on it, because I want them to have a great company that can be making that treatment for decades to come. So that's my opinion on it. I know that other people have other opinions. I'm happy to hear them and talk about them. And so let me know if you have any questions about that stuff.
Yeah, here. I mean, a company that doesn't make a profit is called out of business. So, you know, this nonsense needs to stop. Like, we want, and let me tell you, the companies that are publicly working on SYNGAP, Stoke, Praxis, Regel, others I can't name, are spending a lot of money advancing SYNGAP research, right? And are sponsoring this biorepository that, frankly, we would have to do a lot of bake sales for. So, or not this biorepository, this biomarker exercise. So yeah, I'm with Terry Jo all the way. But the good news, it's not that binary though, right, Terry Jo? Like, yes, we should put these in a biorepository and encourage science, both industry and academic, to work on it. But they don't come with your kid's name on them, right? We go to great lengths to use industry best practices to de-identify them. But this idea that, oh, somebody's going to make money one day, hallelujah. Because if they're making money, they're doing something people will pay for, which is a therapy that our kids need, right? And so I don't want to conflate. I think there's two conversations. Is industry bad? No, industry is desperately needed. Is my privacy protected? Yes, your privacy is protected. And those are two separate conversations. But
Yeah,
if anyone's got questions,
yeah,
Terry Jo.
I definitely don't want to make you think for a second that you would be identifiable, because you would not. Your child, your sibling control, the parents are not identifiable. Once the sample goes into the biorepository, it's completely de-identified. What we do attach to the sample is the variant, so we know which mutation is there. And we will attach some of the phenotype data, meaning, has the kid recently had a seizure, or what are his abilities in terms, or her abilities in terms of developmental abilities. So we would have those things, but it's not identifiable. So very important that I didn't muddy the waters there. I got to make a plug for my next project that's coming up. Okay. The next project we have is going to be an EEG repository. And so here we are sticking blood and urine and whatever else you have in our biorepository. And we're going to be using that for a lot of experiments. But we also need EEGs in a repository. And that might seem kind of weird, but it's very similar to having the blood in there, because EEGs themselves are a source of biomarker. So for Angelman, we ran this natural history study for 15 years. And while we were doing that, we collected so many EEGs, let me tell you, from hundreds of kids all around the world. And those EEGs were in all different kinds of software. They were in institutions all over the place. And really, for the first 5 or 10 years, hardly anybody ever even looked at them, because it's just so much data and so much to go through, and nobody really knew how to handle it on a big scale. And so they weren't all put in one place. Once we got treatments coming down the pike, antisense oligos, gene therapies, repurposed drugs, new compounds, everybody needed a biomarker. And people started looking at those EEGs to see if they could find a pattern that was consistent among people with Angelman syndrome. We had to do a hell of a lot of work, we meaning the field, not me personally, to be able to make those EEGs all analyzable by one kind of software or in one pile or by one researcher. It took a lot of work, but we did it. And what we found in the end was there is a biomarker in those EEGs, a certain pattern. It's a delta, high delta pattern that is a biomarker for Angelman syndrome. Okay, so that's cool. We have a biomarker for Angelman syndrome, but what if you make that better? Does it matter to the kid? Okay, this is the really cool part. You reduce that abnormal delta, it turns out you can also tell that kid is better, the motor skills match. So as that kid gets better, as the motor skills get better, the delta power is going down. So that delta power is now a great biomarker for treatment for Angelman syndrome. We want to have that for all the disorders in combined brain. So what we need are hundreds and hundreds of EEGs, and we need them all collected in the same way. And we are working on that right now with a working group. This one will also be funded externally, meaning that your foundation will not have to pay for the collections. We will be collecting these EEGs at your house. We will send a technologist to your house to collect the EEGs. We will also have to ask you the same old surveys you had to fill out for the blood samples. And we will de-identify all of that. And we will put that in a repository so that people can study those and see if they can find good signatures that are consistent, maybe even consistent with the blood biomarker. So that's our next project called, it's the EEG repository. Is that not exciting? You're not excited?
Oh, I'm so excited. People know that I've been obsessed with EEG. We need an EEG biomarker more than, forgive the expression, damn near anyone, because I think a lot of these diseases have seizures that you can see, and SYNGAP seizures are hard to see. So when when we find an EEG biomarker for SYNGAP, I think it will remove one of the major barriers to SYNGAP in trials, which is, I mean, we've already had, I can tell you already, we had one company come, and if you remember the SSB, the sleep, seizure, and behavior survey we did through Citizen, a company did a survey with us to test if there were enough reportable events. And people did the survey, and guess what? There weren't enough reportable events. And guess what? That company is looking at another disease now. So it's a very real risk for SYNGAP that because we don't have reportable seizures, people don't know what to measure and therefore will not pursue us. Now, this was a repurposed drug that will hopefully come available for us later in life. I'm watching it, but this is a real risk. And I think the EEG biomarker is a massive thing that, like every other massive thing we should do, I'm grateful we can do it in partnership with COMBINEDBrain, because we have Terry Jo Bichel's expertise, her network, and SRF is a strong player, and we're stronger with COMBINEDBrain.
Thanks. Cool. Any other? So that one's not ready yet for prime time, but it'll be ready soon. So do the blood this year, do the EEGs next year.
Believe me, we will.
Yeah. Other questions? I thought I saw some more coming in the chat, but are you guys reading them out of the chat? Will it be in Denver?
That's just me.
Okay.
I hope so. Okay.
The you'll be collecting at the STX one, right?
There is one in Denver, and yes, we will be in Denver. I'm just a little worried because I don't know if we got the formal written permission yet. So
Okay, we'll see.
hold off
Okay.
on that until I give you the whole list, okay?
Okay.
Okay. Does somebody else have a question? We're out of questions.
I think
Thank
we're
you.
close. Thank you, Terry Jo. This was awesome. Mike, I'll let you finish up. And
No, that's it.
Wait, is it?
I gotta say one more thing. Syngap is hot. And I'm telling you, and part of the reason people ask me, why is there so much attention towards Syngap right now? And because really, you don't have, there are other disorders in COMBINEDBrain that have similar incidents. There are other disorders in COMBINEDBrain that have similar symptoms. Most of them have similar symptoms. So why is Syngap so hot? I'm going to tell you why Syngap's so hot, because you guys have done a whole bunch of work to make it easy for people to do research on Syngap. I'm not kidding you. All the stuff that you put at Citizen, all the stuff, the natural history that you're collecting, the samples that you're collecting, the research that you've been funding, it's working. People are noticing. They talk to me and ask me about Syngap a lot. And by people, I mean researchers, industry members, clinicians. Syngap is hot. And it's because you all have made it hot. And it seems kind of weird to have to make a rare disease hot. But I'm telling you, the easier you make it for people to do research, the easier they will actually find a treatment for your kids. And you're doing it. That's all.
Thank you.
Terry Jo.
I didn't write that.
No, you didn't. All right.
Awesome.
Thanks so much, y'all. That was
Bye.
fun. And I'll be seeing you around.
Okay.
Thank you,
Talk
Terry
to you
Jo.
soon.
All right. Bye.
Bye.